Hey everybody, Peter Diamandis here with our May webinar, which I am so excited about. You have to excuse me for being a few minutes late here. I'm looking at the clock in the conference room here and it's broken instead of looking at Marissa or my watch. I'm here with Louis Rosenberg, who is the CEO of Unanimous AI. Louis, welcome.
Yeah, great to be here.
I should say Dr. Louis Rosenberg. Let me just, so we're in for a treat here on something that I've been really looking forward to ever since I heard about what you're up to. And for all of you who are entrepreneurs, CEOs, all members of the A360 community, this is something that you're going to want to know about, play with, use, employ. It is huge. So get ready for a fun hour. Let me read Dr. Rosenberg's bio first. He is the CEO of Unanimous AI and has been pursuing his passion and interest in collective intelligence and human-computer interaction. He was recently named AI Person of the Year by the Informed AI Media Group, who described Swarm AI as the single best hope we have for keeping humans relevant in an AI-dominated future. It's that big. All right, so he attended Stanford University. We got his bachelor's, master's, and PhD at Triple Play there. His doctoral work was focused on robotics, VR, and what is HCI?
Human-computer interaction.
Okay. Like BCI. Okay. So anyway, while conducting research at the U.S. Air Force Armstrong Lab in the 1990s, Rosenberg created the Virtual Fixtures platform, the first immersive augmented reality system ever built. One of my favorite areas to go and play in. He founded the Immersion Corp to pursue virtual reality technologies. The company went public in 1999 on the NASDAQ. That was quite the year roller coaster ride, I bet. And Rosenberg also founded Microscribe, maker of the world's first desktop 3D digitizer. Let's see, Rosenberg also worked as a tenured professor at California State University, Cal Poly, over 300 patents. And lives in St. Louis Obispo and commutes up to the Bay Area on a regular basis.
Yep.
So let's kick this off. What you have built with Unanimous AI has been nothing short than miraculous in its predictive capabilities. So just for fun, let's rattle off a number of the things that you've used swarm intelligence, or what you call predictive intelligence, to predict, if you don't mind.
Sure.
Yeah.
So one of the things we do is we allow journalists to challenge us to predict things. And so we were challenged to predict the Kentucky Derby last year by CBS Interactive. And we'd never done that before. We didn't know anything about horse racing, but we built a swarm intelligence. And predicted, they asked us to predict the first 4 horses. In horse racing, that's called the superfecta. And so we predicted the first 4 horses in order. And then the reporter actually went to the Kentucky Derby and tweeted out her ticket.
Did she bet on it?
She bet on it.
And she won the...
And anybody who bet on it, if you bet $20 on those 4 horses in order, you would have won $10,800 because it was a 540, and so I bet $20 and I won $10,800. One of her readers actually bet and won $50,000 by betting on her what she tweeted out from the Kentucky Derby.
I think the proper term is holy shit.
and the way we did that, and what we do is we build AIs in a very unique way where we take real people who are giving real input and we amplify their intelligence. Right. And so in this case, we just took 20 horse racing enthusiasts. We had them come together on our platform, which is called UNU, and we built a swarm out of them, and we asked them to rank the horses in order as a swarm intelligence, and they predicted those first 4 horses in order perfectly.
Okay, so we're going to come back to that. Give me some of the other predictions that you've hit.
So we were, the last 2 years in a row, we were asked by Newsweek to predict the Oscars. And so we built a swarm of movie fans, just regular movie fans, and we asked them to predict the Oscars. And what we do usually is we take a baseline where we have people just predict on their own as individuals. So these 50 people came into our system, they predicted on their own, they were 44% accurate in predicting the Oscars, which doesn't...
As individuals?
As individuals, which doesn't sound that good, but predicting the Oscars is pretty hard. And then we had them work together as a swarm basically an emergent intelligence, and they were 76% accurate in predicting the Oscars. And what's interesting is you can compare that to professional movie critics who average 66% accurate. So what we do is we take enthusiasts and we turn them into expert level performers by having them basically think together as this emergent system, as a swarm intelligence.
And how many experts constitutes a swarm?
So it's we generally build swarms between 50 people and 150 people to amplify their intelligence. And
wow.
and we keep looking at does it make a difference to go bigger and bigger and bigger? So far we're seeing diminishing returns by going way bigger. But when
that's a relatively very manageable number of 50 to 150 people.
Yeah, and it was inspired to us by from how nature builds swarms, and we can talk about that when we get into natural systems. But
okay, give me a couple others. What else have you? So the Oscars you predicted correctly 2 years in a row.
Yeah. The swarms outperformed professional movie critics 2 years in a row. We were asked by the Boston Globe to predict the baseball season last year at mid-season, at the All-Star break. And what they did was they gave us 50 of their readers, and they said, okay, take 50 of our readers and build a swarm. And they predicted at midseason all 8 teams that made the playoffs.
Wow.
They predicted that the Cubs would face the Indians in the World Series, and they predicted that the Cubs would break their 100-and-something year drought and actually win the World Series. The swarm predicted would win in 6 games. It took the Cubs 7 games.
Are you guys hearing this? Isn't that incredible? So I have to ask, I mean, my first reaction is, I don't doubt that this is true. I mean, I believe you, but are you going to ultimately destroy betting pools?
So
I'm like sitting here waiting to ask you after the show, what have you predicted that I can go put $20 on?
Yeah, we've done.
I'm taking you to Vegas.
we actually just did a rigorous study with a researcher at Oxford where we predicted English Premier League soccer games.
Okay.
And we did it over 5 weeks, so 50 games over 5 weeks, so we can really get a long historical data. And what the analysis that came out of Oxford showed was that if you looked at those individuals who predicted on their own these games, the swarm was 130% more accurate than the individuals. And so while we can't say that the swarm will always be right, the swarm is almost always smarter than the individuals who make up the swarm.
And you did some correct predicting on politics as well.
Yeah, during the election season, we did a lot of swarms. We predicted we predicted the primary season, and during the primaries, very early on, the swarms were predicting Donald Trump would be the nominee. It was so early that the polls were not saying that, and we started to think maybe our algorithms were wrong, but the polls eventually caught up. We just did a political prediction for Modern Trader magazine right before Donald Trump took office. They asked us to predict his 100-day approval rating.
Yeah. And
so what we did was we pulled together a swarm of 75 average voters, and this was in early January before he took office, and they predicted that his approval rating at 100 days would be 42%, which turns out to be exactly what his approval rating was.
Can I ask a question? So today's date is May 15th. What predictions do you have out in the near future that you published or you can speak about here?
Oh, that's a good question.
Anything in particular that you remember?
Not off the top of my head, but on our website we post a lot of predictions.
What is your website?
Just unanimous.ai.
Okay.
On our blog, we predict sports every week. There's predictions for there's the Stanley Cup going on. There's predictions.
Have you impacted the betting pools out there?
I don't know that we've impacted the betting pools, but this year, after we predicted the Kentucky...
There's still a chance for you to get an advantage on the betting pools.
After we predicted the Kentucky Derby last year, this year, the organizers of the Kentucky Derby actually partnered with us. So we work with Churchill Downs, who runs the Kentucky Derby, to help them actually handicap their betting pool this year. And so I think there's definitely places where tapping the intelligence of human populations will help set the betting markets.
Okay, a slew of questions, but you call the company Unanimous AI. You mentioned earlier you've got on the order of 25 employees as part of the team up in the Bay Area. What is the AI part of Unanimous AI? What I hear you saying is we're going to gather randomly a group of 50 or 100 people. Where does AI play a role in this?
Right. So we use we use a number of different techniques. We use some traditional machine learning techniques as part of our algorithms, but really the more interesting way to think of the AI is to look at just to put swarm AI in the context of AI in general. Most AI research that started back in the 1950s has said, well, how do we build an intelligence? Let's look at the most familiar intelligence we know, our own brains. And so all the research that's really gone on so far has been to simulate neural intelligence, neural networks, neural structures. Nature actually has another way it builds intelligence, which is it builds collective intelligence, or what biologists call swarm intelligence. And so we've been modeling our techniques. Instead of building artificial neural networks, we've been building artificial swarms, modeling our algorithms and methods after how bees and birds and fish swarm to amplify their intelligence. And so we're building basically artificial swarms in kind of a parallel way to how traditional AI builds artificial neural networks.
So if you could, let's go one level deeper about what does a swarm mean, and just give, and then I want to talk about how you started, and then if someone here wanted to engage your company, what does that mean? Right.
So, kind of taking that step back, our technology and the whole concept of building swarms was inspired by nature, and so we. If you look at how social organisms evolve, most creatures follow this path where first they're going to develop their individual brains, and they're going to develop this individual intelligence, and then at some point when they need to reach a next level where the whole species needs to get smarter, they build a swarm intelligence.
So and sort of a brain of brains, as you've called it.
A brain of brains. And so if you think about it in terms of systems, a brain is a system of neurons that works together, and an intelligence emerges from that system. Then nature takes that next step and builds a system of brains, and a superintelligence emerges from that system of brains. And it's really interesting to talk about how bees do it, because it's really, people don't normally think about bees as being smart, but they've built a superintelligence by swarming. And so, and the thing to know about a bee is an individual bee is really, really simple. It has less than 1 million neurons in its brain, as opposed to humans that have about 80 billion. Yeah. So less than 1 million neurons, brain is smaller than a grain of sand, and they have a really difficult problem to solve every year. So every year, bees will split their colony in half, and 10,000 bees will go out, and they need to find a new home. And so those 10,000 bees have this challenging problem. How are they going to find a new home? And what they do is they send out a few hundred scout bees that are going to basically search the world for data, for information about potential homes. And they're going to bring that data back to the colony, and now they need to make a decision, which home should we move into? And they'll find a couple dozen homes. And by homes, I mean like a hole in a log, or the hole in your attic, or a hole in the side of a building. And it turns out this is a really complex, multidimensional problem, because when they pick a new home, it needs to be large enough to store the honey they need for the winter. It needs to be insulated well enough to stay warm in the winter. It needs to be ventilated well enough to be cool in the summer. It needs to have an entrance where bees can come in and out, but predators can't come in. It needs to be close to pollen. It needs to be protected from water. Really complicated problem. And it turns out that bees pick the optimal solution 80% of the time. And so if you think about that, you say, well, here's a bee that has less than 1 million neurons. It's however smart a human is, divide that by 80,000, and that's a bee. And yet these bees, when they work together as a swarm, are able to solve a problem that a human CEO would find challenging. If you were a human CEO and you were trying to find, where should I put a new factory? And I was considering all these different parameters, it would be hard. And yet these bees, when they work together in a swarm, can pick the optimal answer 80% of the time across this complex multivariable problem. Now, how do they do it? They don't take a poll, they don't take a vote, they don't take a survey. What they do is they form a system. And by a system, it's a real-time, closed-loop system where 300 to 500 bees are literally working together in real time to negotiate and find what is the best solution.
That's incredible.
And the thing is, they're literally sharing data with each other. And so what these bees do is that they they go out, they search the world, and then they come back and they vibrate their bodies.
They do a dance.
They do a dance, and biologists call it a waggle dance because it looks like a dance, but they're literally vibrating their bodies to convey which of the different sites that they find to be the highest preference. And so they express their preference and their level of conviction in all these different swarms and in all these different sites. And so they're negotiating in real time, pushing and pulling as basically a massive tug of war. And so this massive tug of war where factions are forming and dissolving among bees until they converge on that one solution that they can best agree upon. It's not necessarily the most popular solution if they had taken a vote on at that first moment, but it's the solution that they can converge as a system that achieves their collective satisfaction.
So let's walk us through so you guys properly predicted midseason the Major League Baseball, and I think we have a video to share. Let's play that, and let's use that as an example and walk us through the step-by-step of what you did with the MLB organization.
Right. So what we did, and the example that you'll see shows a swarm of about 100 people who are picking who's going to win the World Series. And what we did was we modeled this after bees. And so we have these 100 people, and we asked them to be scout bees, go out and educate themselves about baseball.
100 fans chosen at random.
100 fans chosen at random. We say, okay, we're going to predict the baseball season. Educate yourself if you want. They can go spend a little bit of time, and then they'll give us their individual predictions just so we have a baseline. But then they're going to come together in a swarm. And what happens, and what you see on the screen is one question of what would maybe be 20 questions as we went through the whole baseball season.
Right.
But what happens is they all log into our system. It's called UNU. And the question appears on all the screens at the same time. And what you see is that each person has a little magnet that they can control to pull on the swarm. And the thing is, it's modeled after how bees make decisions, but we humans can't waggle dance. So we had to build a user interface that allows the participants in a swarm to express the same vectors that a waggle dance does, express their level of conviction and vary it in real time. And so each person controlling a mouse or controlling a touchscreen is pulling on this glass puck. They're applying their will, and they're negotiating in real time. They're pushing and pulling. If everybody's pulling in a different direction, it doesn't go anywhere.
Right.
And so people vary their prediction.
And how long does that process of pulling take place for?
So a single question, we always keep it in 60 seconds or less. Okay. And so in 60 seconds or less, people are pushing and pulling, and if everybody's pulling in a different direction, it doesn't go anywhere, but it will find that path that optimizes their collective satisfaction. It won't necessarily be the most popular answer, but it's the answer that they can best agree upon.
So when you interview somebody after they've gone through that 60-second period, what are they saying?
They're saying a lot of things that really surprised us. One of the first things that we really wondered about was, did you feel consequential? Because there's 100 people all working together. And they all said yes. They all say, I felt like I was in control, which is so different than if you ask people like, oh, if you took a poll, if people feel like, I feel like I had no impact. I put a piece of data into a poll.
I'm one of 100.
I'm one of 100. Yeah. But when they're part of a swarm, they feel consequential. Even if the answer ends up someplace that wasn't where they were originally polling, they feel like they were part of the system.
Fascinating.
And it's one of the big differences between a poll and a swarm. And so when people take a poll, you're asking them to provide a single data point. When they're part of a swarm, we're asking them to be a data processor. We're asking them to participate the entire time. They're varying their opinion during the entire decision, and they're working with everyone else to find that one answer. And
so will the answer actually sometimes take all 60 seconds to get there, or sometimes it gets there quickly?
It can. And so there's another example. I don't know if you guys can bring it up, but there's an example, I think it's image 1, that during the political season, we asked a question of what's the most important issue in the presidential campaign, and that's political questions are contentious,
are charged.
And so here the swarm was pulling a lot of different directions. It was going towards taxes actually, and you can actually see in the replay the swarm starts going towards taxes, and then it changes direction, and it ends up on jobs, and it's a great example of how the group will converge on the answer that they can best agree upon. An example that we often give, because it's really simple to get your head around, is imagine a swarm where we're going to ask a question, where should we go for dinner? Right? That could be a contentious question. Now, if I had 6 people and I said, where should we go for dinner? I could say, let's just take a vote. and I might have one person vote for Italian food, one person vote for Mexican food, one person vote for Chinese food, and maybe 2 people voted for Indian food. Well, we took a vote, the most popular answer was Indian food, we're going to Indian food. Well, does that mean that we maximize the collective satisfaction of the group? No, because 4 of those people might have hated Indian food, or maybe they had Indian food for lunch, and so they just don't want to go there. But a swarm is a system with feedback. So what would happen in a swarm is
and continuous feedback.
Continuous feedback. Every 200 milliseconds there's feedback. And so what happens is one person's pulling for Italian food, one person's pulling for Mexican food, 2 people are pulling for Indian food, the puck starts moving to Indian food. But all those other people, they're not just data points, they're data processors. They react. And so when they see the puck moving to Indian food, they change their pull. They might go from pulling from Italian food to pulling to Chinese food. Or maybe they go to defending against Indian food.
Right.
And so the swarm starts to move in one direction, then it starts to move back. And if instead of it being 6 people, if it was 100 people, and they're all varying their opinions, it will find that path to the answer that optimizes their collective satisfaction in the answer.
So how many questions typically make up a process here? And how do you pick those questions? So I'm the CEO of, well, let's say at Abundance 360, we have 360 CEOs and entrepreneurs in the audience. And let's say we want to use this to put forward questions. And I think if you guys are into this, I think we should try this experiment. I don't know what you guys think. Marissa, work with you to become a customer to Lewis here, and we can play this because I don't know about you, but I'm fascinated about this. So let's say we wanted to do a poll of. I just read this morning that that Waymo, which is Google's autonomous car spin-out, is partnered with Lyft to go into the autonomous car business as a strategic move against Uber. Right, and it's a hell of a strategic move, let alone the lawsuit going on between Google and Uber right now, putting that aside. But let's say we wanted to ask a few different questions, like who would win the lawsuit? I don't know if you do those kinds of predictions, or when will the first autonomous car ride be given without a human safety driver in that seat? How many questions, I mean, is it simply one question like that, or is it a sequence of questions? Right. How do you think that through?
Usually we do it in under 20 questions. And it's really just about the convenience for the people who are involved. Because the one thing about a swarm is that it's a real-time process. Everybody has to participate together at the same time. But each question takes less than 60 seconds. So usually the whole thing will be about 15 minutes.
But how do you parse a question like who's going to win the Super Bowl or the World Series into 20 questions when it's just a single question?
Right, and so...
or do you move them incrementally towards that goal?
We try to move them incrementally. And part of it is just to get the group to be thinking about the sub-factors that make up the answer. So you might say, which team has the stronger defense? Which team has a stronger offense? Which team has the better quarterback? And so we can ask a series of questions and ultimately get to this answer of which team's going to win the Super Bowl.
So I'm assuming then the sequence of questions that ultimately builds towards the final answer will have a better result than just asking the final question. Is that true? Have you tested that?
We believe it's true. We don't have a rigorous test of that issue, but we believe that's true in that it's if nothing else, it's getting the group to think about the question critically, so that when they do answer the final question, they've at least pondered it, their own thought process.
So you call this predictive intelligence,
right?
And the service that you offer to companies is called Swarm Insight,
right?
How do you, if you don't mind me, how do you price that if someone here wants to become a customer?
Right.
How do they do that? Do they contact you directly? Do they walk me through the process?
Right. They contact us. They contact us directly on our website, and
the URL is
unanimous.ai.
Okay, perfect.
And if they want to, basically Swarm Insight is a service where they would have a project, and usually we would just bid the project because every project's different. Some are relatively small, and some are really extensive. But
do you mind giving me a price range for this? Small to large, or if you don't want to.
Yeah, it really just depends on it depends on how big the project is.
Okay.
So everyone is different, but the type of projects can be, anything from, forecasting a business space to assessing how people will react, how the public will react to new messaging or new marketing.
I mean, can you add do you give people, so in the past, if you had an ad you wanted to play for a movie or for a product, you would do a focus group. But you're saying swarm intelligence gives you much better results than that.
Right. So a focus group.
What's the difference of, if I could, focus group, wisdom of the crowds, which is different from what you're doing? Right.
So traditional ways of tapping the intelligence of a group would be, taking a poll or running a focus group. And the thing about a poll is it will give you the average answer. It will give you the average solution. It won't tell you what the group can best agree upon. So I could ask a group, which of these, in fact, we did a question about self-driving cars for TechCrunch about 6 months ago. And the question was, what's going to be the most important feature to drive adoption of self-driving cars? And there was a bunch of different choices, safety, gas mileage, time to do other things. There was a bunch of choices. And and they were taking a poll, and the polls kept saying the most popular answer was safety. But it was a small margin. It was like 30% said safety and 20% said something else. But when we asked them to work as a swarm, the group had to push and pull and converge on an answer, and they went to time to do other things. And so the answer that they could best agree upon was different than the most popular answer. It was time to do other things. It was, and so what we
would be more valuable than the safety feature. Interesting.
It was what this group predicted was the thing that would drive adoption. And so, in some sense, and when we interviewed people after to say, well, what do you think happened? They said, well, a lot of people felt like they should on their survey just write safety down because it seems like the answer you should say. But when they were part of a swarm, they felt like they could be more honest. They saw the group converging and they saw the group moving and they converged on time to do other things, which we believe
was a more honest answer.
Which was the more honest answer rather than the answer people thought they should give.
Interesting, right? So that's a fascinating element here.
And that's the thing is that we get that feedback a lot from people that the swarming process encourages people to give honest answers as opposed to giving answers that they think other people want them to give. Okay. You also asked about focus groups, and focus groups have other problems, which is they're relatively small groups, 12 people, but they generally the loudest voice in the room dictates a focus group, and so focus groups are really swayed by the people who are in the room. In a swarm, everybody's equal. There is no loud voice. There's no soft voice. Everybody's anonymous, everybody's equal, and so you get to the answer that is a much fairer representation of the different opinions as opposed to...
How educated do your participants need to be on an issue? So if I'm CEO of an organization and I've got a company like here at X Prize where we have 100 individuals and we're running these X Prizes, if I wanted to use a swarm intelligence to predict, when will the $30 million Google Lunar X Prize get won, and who will win it, this audience here of 100 people are probably more in tune or more educated than the general public. But would I expect them? Are they going to be? Is this a surprise quiz to them, or do we tell them we're going to be talking about this, go out there and do your research and then come back on Monday at 10 a.m.
Right. So, I mean, we encourage people to generate their opinions in advance, to go out and research issues, to be those scout bees that are out there searching the world for information and then come back. Because what we're going to do is we're going to allow the people who have this intelligence in their heads to find the answer that optimizes their collective confidence and satisfaction and interest in the different issues. And so educated people who are aware of the topic are the best people to form a swarm.
Interesting. Get your questions ready. Marissa will be reading them out loud. I mean, I hope you guys are as excited about this as I am, because I find this sort of like the It's about, it's definitely about predicting the future and creating the future and all kinds of things. One more question, well, two more questions for you. How easy is it to create the questions and to go, if I have my team and I'm like, I need to know this later today, can I create questions and put it out to them if it's a subject they know about and do something pretty rapidly?
Yeah, so we work with journalists all the time, and those, for those types of topics, the questions have to happen quickly. Or for sports, like the game's going to happen tomorrow, the questions can go out, and so it's a very fast process. And then
last question before we go to the much more intelligent questions from the crowd here, is ultimately, how did you start? Why did you start the company? What's the origin story here?
Right. So as I mentioned, when we started, I spent my career really focused on human-computer interaction, and I started in virtual reality and augmented reality because my interests have been how do you use technology to amplify human performance. And so I started, when I was working on virtual reality and augmented reality, I was focusing on single people. How do you amplify the performance of a single person? And then along the way, I realized it becomes much more interesting when you start saying, how do you amplify the performance of groups of people? And so I started looking into how can groups of people be smarter together, and that's what led me to looking at how nature does it, and I was just blown away by how...
And you formed the company what year?
2014.
2014. All right, so speaking of groups of people and much more intelligence, let's go to the crowd here. Marissa, tee us up.
So I've got a couple similar questions from Francis and Sky.
How does swarm intelligence compare to the collective insights gained by collecting social media data to predict the last election? Or is swarm AI better at prediction than silicon-based AI?
Right. So looking at social media data is interesting and is valuable, and people can generate insights. The way I look at it is that the techniques that go out there and scan the internet for information are looking for the trails left by people. Mm-hmm. And that's useful. What we do is say, well, how about we just bring those people together and we actually pull the information right out of their heads. And so when we build a swarm intelligence, what we're doing is we're asking people to come together, and we're use the knowledge and insights and wisdom and intuition that they have in their heads together as a system. And we think that's the more direct way to get at the collective intelligence of a group than to look at the trails that they leave behind.
Fantastic. Marissa.
This next one is from Brendan, who asks,
what is the minimum size of a swarm?
That's a good question. We do swarms that are as small as 5 or 6 people. We try to tell people that it becomes most interesting when you get to about 10 or 12. When we're doing a prediction for a sporting event, we try to go for at least 50, but 50 to 100 to 150 are really good swarms for doing predictions. And again, honeybees, it's interesting, we always go back to nature. Honeybees have 10,000 bees that have to go find a new home. When they form a swarm to make a decision, they only use 300 to 500 bees. And so it's probably, evolution has probably found that there's a diminishing return when you go beyond a certain number.
And it's interesting, right? For humans, our memory, we can remember on the order of 150 people, which is thought to be the original sort of tribe size. Mm-hmm. Yeah, Marissa.
Colin asks, how does swarm intelligence differ from ANP or AHP techniques?
So the thing about swarm intelligence is that what we're doing is we're taking the intelligence of real people in real time, and so we're not asking people to give data in advance. We're not going through data sets or doing big data analysis. What we're doing is we're saying you're going to come together in real time as a system with closed loop feedback, so that you can literally push and pull on other people, and so because we're allowing everybody to push and pull together, they can converge on an answer that, again, it might not have been the most popular answer. It might not have been the answer that if you just looked at the trails or looked at the big data, you would see. Instead, you're going to see, well, what can the group converge upon together in real time? What is the answer that will best satisfy that group? And it's for things like opinions, we get opinions that are more likely to satisfy the whole group. And for things like predictions, we're more likely to be to be considering the wisdom and knowledge and intuition of all the participants.
Awesome.
Brandon is very interested in using human swarm AI to train and confirm silicon AIs. Has work been done in this area?
It's an interesting question. It's something that we've been looking at and thinking about, and it's definitely a viable approach, because what way we look at it is when we build a swarm intelligence from people, we're taking a group of people and we're turning them into a super expert on whatever the topic. If it's a group of football fans, we're building a super expert football fan. Well, that super expert can then be used to train a machine learning system. And in fact, we can build a bunch of swarms. And each of those swarms, we could have a whole group of super experts. And so it is an interesting and valuable way to think about things.
This next one is from Sunil. Could the swarm be used to predict the right talent for a team?
It could. And so things in the HR space in terms of predicting
interesting. Like who do we need to hire next?
Who do we need to hire next? And we get that request a lot from potential customers, because hiring is a really difficult decision. People have strong opinions, and they are all looking at the problem from different perspectives. And so you might be looking at, one person might be doing a hiring decision and thinking the most important thing is experience. And somebody else might be doing a hiring and think the most important thing is personality. And somebody else, and so everyone has, when it's like the bees making that decision about where to move, there's a lot of different ways to look at the problem of hiring, and how do you aggregate those different opinions?
Interesting. I wonder as well if you have like 5 or 6 candidates and a group of 20 people who interview them all, and then using this as a mechanism to identify who you're going to hire. Because if this guy's my first choice, but this guy happens to be my 4th choice, and the group moves him up, wow, that's interesting, because it's taking into account multivariable elements.
It's a multivariable problem, and every person is weighing those things in their own head. And it's hard for people to verbalize even the relative importance of these. They might, each individual might not even know the relative importance of the different factors in their own head. But when they're behaving in a swarm, it's coming out naturally. And so they're all behaving naturally, and they're finding that solution that they will be most satisfied with. And we've done studies where we've had people rank priorities, and we can ask them to rank by just voting or rank as a swarm. And when they rank as a swarm, the group will then say that, they're more satisfied with the solution that came out when they work together as a swarm intelligence.
Wow.
This next one's from Francis. Can swarm AI be used to solve complex problems like global warming?
It's a great question, and it's one of these things where if we can break that problem up into sub-questions that we could then ask the group, then we can definitely generate insights. And this brings up another topic that is related, which is this issue of morality of swarms. And it's something that we've thought a lot about. And we thought about that because in science fiction, there's kind of a negative connotation of this idea of a hive mind. And there's the Borg. And we said, if we build a swarm of people, is that going to be a more moral or less moral than individuals? And so we actually did experiments on this. And so we did what's called Tragedy of the Commons experiment, where we wanted to see if a group was going to vote in a traditional vote versus a swarm, would they be more or less moral? And so the Tragedy of the Commons experiment that we did is actually really fun and interesting one, where there's a classic experiment where sometimes professors will ask their class, Tell me as extra credit, do you want 5 points or 15 points as extra credit on your exam? I'm going to give you whatever you put on your exam, with one caveat, which is if more than 1/3 of the class asks for 15 points, nobody gets anything. And so this is a tragedy of the commons where everyone has to be selfless. I mean, the right answer to maximize the points to the group is for everyone to put down 5 points. And classes always fail. More than 1/3 always put down 15 points. And so what we did was we said, okay, let's take groups of people and let's break them up into teams. And we had like 3 teams, and we'll say, tell us if everyone on your team should get $5 or $15 bonus. And we asked them to do it as a vote, and all the teams voted for $15. Then we asked them to do it as a swarm, and two out of 3 groups, every time we did it as a swarm, asked for $5. And so the swarms were more selfless. The swarms actually solved the tragedy of the commons problem.
Interesting. And I wonder if you had anonymity or non-anonymity, how that would...
And in this case, they all had anonymity. We try to hypothesize, why is it that a swarm is more selfless, is actually trying to do what's better for the greater good than a vote? And we think it's because a vote, you're putting a single piece of data into a black box. You don't really feel responsible for the outcome. You feel like, yeah, I voted, but I'm not responsible for what the group. But a swarm, people feel responsible for they feel like they participated, they feel part of the system, they feel responsible, and they actually take greater they feel like there's a greater moral obligation on themselves when they're participating in a swarm. And so ultimately, we think that swarms actually would be good for solving problems like global warming because it would help people make better decisions than we do in the current way we aggregate our opinions.
Amazing. Marissa.
Could a swarm intelligence predict stock market movements?
That's interesting. We've been doing a number of studies about that. We've been actually doing...
the prediction is that we'll have a bear market sometime soon. We're overdue for it. And I would love to know what the swarm intelligence
we've been actually doing experiment where we've been having groups of people predict, doing weekly stock market predictions. And the swarms are outperforming the individuals who make up the swarms every week. And again, it's one of these things where we never can say that the swarm will be, how accurate the swarm will be on an absolute scale, but what we do know week after week is that the swarms are smarter than the individuals who make up the swarm.
Amazing. Like, will Tesla's stock continue to be anti-gravity? All right. Marissa.
What other data besides the final answer is available or collected by a swarm intelligence? Can we learn about the people who are participating?
So we do, we actually collect a lot of data, and it's actually really fascinating. So every 200 milliseconds, we know exactly which way every single person is pulling and how strong they're pulling. And so we can do an analysis, we call it faction analysis, where we can actually see how the factions form and dissolve during a decision. And so at the end, we don't just get a final answer, we can actually see how did that answer come to be? How did that answer evolve? Which types of people were pulling in different ways, and we can look at them from a demographic perspective. And so we kind of think of it as almost giving a CAT scan of this intelligence. So we can look inside and see why did that decision come to be the way it was.
I have a mental model of this process being sort of a vector summation going on at any one time, where I'm just basically adding everybody's force and direction. Again, help me understand where the AI element plays in here.
Right. So there's this kind of simple physical model that you see when you look at the swarm on the screen, and at the highest level, everyone is pulling on the pucks using this vector model. The mathematics that goes on behind how we aggregate those opinions is more complicated than that. Mm-hmm. And so our algorithms are actually looking at the behavior of people, not just the vector that they're putting out. Because what we really want to do is not just know what your opinion is, but how strong your conviction is. And so our algorithms are assessing conviction levels based on behavior. And for example, if somebody's pulling, just continually pulling for a certain answer, we know that they probably have high conviction. If somebody's switching around, they have lower conviction. And ultimately, what we really want to know is what's that answer that will maximize their collective conviction. And so the algorithms that happen behind the scenes are doing a lot of interesting things, but when you're performing, you don't experience that. It's all very natural and intuitive at the front end.
So one of the books that I read that I really enjoyed was a book called Super Forecaster. But Super Forecaster is about finding the person in your organization who's the best forecaster rather than using your organization as a whole. And do you have a sense that the swarm will always outperform a super forecaster?
So super forecasting is really interesting, and it's about, why are some people better at making predictions than other people? And it's definitely a skill, and there are some people who are very good at making predictions because they know how to get away from their own biases and think about things objectively. What's interesting is that a swarm, all these biases that people have cancel out.
Yeah.
And so we solve some of those problems through numbers of people. We do sports predictions all the time, and the thing about sports predictions is that sometimes if somebody's a fan of a team, they'll have a bias. They'll think, we'll ask them who's going to win the World Series, and they're going to end up telling us who they want to win the World Series.
Yeah.
But if we do a swarm, and people can log in from anywhere in the world, so if we do a swarm of people all across the whole country, those regional biases cancel out, and you end up with the swarm, amplifying the intelligence of the group.
Awesome. Marissa.
This next one is from Sky. Have you studied whether a swarm would give us better legislative decisions than, for example, 100 individual senators? Would it overcome lobbying influences?
So there's this issue. I mean, one of the issues that you obviously see in the Senate is gridlock, right? And the thing is, the Senate is an organization that votes. It's basically a vote. The thing about votes in polls, and I think one of the reasons why nature doesn't use votes in polls, is that polls are polarizing. What a poll does is it just tells you the differences in a group. It polarizes a group, and in fact, a poll then encourages the group to entrench in their opinions. And
Interesting, right? I mean, it really drives you to say, "Damn it, I'm going to stick with my original."
And a poll is this polarizing thing, and that's essentially why nature doesn't use polls. Nature, in my view, nature evolves swarms because swarms do the opposite. Swarms allow groups to find their commonality as opposed to entrench on their differences.
Love it.
And in fact, if bees entrenched, if two groups of bees said that they couldn't agree on which new home to go to, they would die. And so evolution, so those bees over the millions of years of evolution, those bees that entrenched like senators, they died, and the bees that could find common ground by swarming, they lived.
Wow. So you're basically re-engineering my political structure for my space colony. This is great.
Yeah. So a space colony, if they want to converge on the answers that maximize the knowledge and wisdom and intuition of the whole population, they should do what nature does. They should swarm instead of vote.
I love this. I hope you guys are enjoying this. I find this absolutely fascinating. Marissa, what do you got?
Here's a common one. How do I decide if a problem I have is a good fit for swarm intelligence?
Excellent question. By our swarm here.
It's usually, almost every problem is a good fit. It's sometimes takes a little bit of thinking to come up with how you word the question in a way that makes sense for the swarm. But the things that are usually the best are things that involve subjective judgments. If you have a decision where where there can be a lot of different perspectives, or there's a subjective judgment involved where human input makes a difference, then a swarm can really amplify the intelligence of the group.
I have a slight variation on that. If I had a group of 500 people and I randomly chose one group of 50 and randomly chose another group of 50 and another group of 50, do I expect those groups of 50 to roughly come out with the same answer? Have you done that experimentation?
We have. If you're truly randomly picking out of a population, you will get the same answer. That said, if you're not randomly picking, each
Cubs fans will vote for Cubs.
I mean, yeah. if I do Cubs fan, if I do regional differences, and so the thing about a swarm is its emergent intelligence is coming out of the group, and it will have a personality that is dependent on the group. And so if I do a swarm of a particular type of person, it will have a personality that will be different than if I do a swarm of a different type of person. And sometimes it's interesting to look at swarms of, and we did that during the election all the time. We do swarms of Democrats, swarms of Republicans, and we get different answers. But we're creating a super expert Democrat that's telling us how that group thinks about the world, and we're taking a super expert Republican and
can you do this as quickly as during an hour lecture, live on stage, run a swarm analysis?
You can. We do live swarms during the political debates. For example, we ran live swarms while the debates were happening on TV, and everyone who logged in was able to watch the debate live, and they were swarming and answering questions.
Awesome. Let's do 3 more questions here, Marissa.
This next one's from Francis. How accurate are the swarm AI prediction models currently, and can they get to 100% prediction accuracy in the future?
So I don't think it'll ever get to 100%. I mean, it depends on what the problem is, but certainly for things like sports and finance, there's randomness. And so one of the things we always have to tell ourselves is that not everything is predictable, and certainly very few things are predictable with 100% accuracy. And so we tend to judge ourselves on not how accurate was the prediction, but how well did we amplify the intelligence of the group. Did the swarm predict more accurately than the group would have predicted on their own?
Next one's
From Terry and Gaia, who have similar questions. Do you foresee having an online tool or an app that people can use on their own to organize a swarm-based goal?
Yes, and we have that. So we have an online platform called UNU that we allow people to log into and form swarms. And that's if you go to just unu.ai. People can,
UNU.ai.
UNU.ai. People can log in and there people tend to congregate there in the evenings to talk about politics and things. It's the public ones are really more for people who are talking about kind of social things or talking about fantasy sports. Businesses would prefer to have their own private swarms, which we also do.
Awesome.
Can swarm AI be used to predict aesthetic preferences, like success or failure of a novel, film, painting, clothing line, etc.?
That's a great application, and we in fact we actually do movie trailer predictions all the time with swarms. And so what happens is we have a movie trailer pop up, swarms watch it, and then the swarm will predict the box office success of the movies. And the swarms are actually pretty accurate in predicting box office from watching movie trailers. We've done projects for companies. We did a project for a big fast food chain where they wanted to predict the reaction to their TV spot. And so the TV spot would pop up and the swarm would watch the TV spot and then predict if that TV spot would have the correct influence on the public.
Have you been using UNU yourself as a platform? Are you using your own machinery to help move your company forward?
We do. When we have tough decisions to make, we will swarm and see what's the right direction for the company. How should we prioritize things? How should we price things? And it's a way to really amplify and just expose the collective intelligence of the group.
And so for a private company, if I wanted to use this for policies, if I wanted to use this for hiring, this is a service that you can deliver and provide.
Yep, and people can log in from anywhere, and they can log in. And again, it's fast. I mean, part of the reason a swarm process is fast is that there's a lot of social science research that shows that people are more honest when they answer questions quickly under pressure, and so we deliberately made it fast. But it's also just convenient because people they have to congregate at the same time. But if you have a group of 20 people who need to decide, prioritize policies, it's if they can just all log in from their own computers, they can quickly go through and prioritize, and it's.
And how many? Just one more point. How many questions are in a sequence to get to a answer typically? We
tend to do 20 or less, and it's really more of a time thing.
Are some just like 2 or 3 or 5?
It could just be just 2 or 3. I mean, the thing is, once people are going to congregate. Once people are going to log in and congregate, they tend to want to do more than 2 or 3 because they're there. And once you get to 20, like if you keep it under 20, the whole thing is under 15 minutes. And so usually, 10 to 20 is what we usually see. But sometimes if something is a complicated issue or there's a lot of, like when we did the Kentucky Derby, there are 20 horses. So you have to go through, and they did a process where they narrow down from 20 horses to 6 horses, and maybe it took more than 20 questions to get through that because there was a lot of different options.
Fascinating. So, first of all, thank you.
Oh, it's fun.
I'm so grateful for what you've built, and I can't wait to figure out how I'm going to use it in my own companies, and then how we'll play with this at Abundance 360. As we've wrapped in this hour, I hope you guys found this fascinating, and this reminds me of sort of Asimov's Foundation trilogy in terms of the ability to predict large-scale human dynamics. So there you have it. For our May webinar next month in June, I'm very proud to bring a dear friend, Shervin Pishavar, on the webinar with me to talk about moonshots. Shervin is the managing partner of his venture fund, Sherpa Ventures. He is one of the largest investors in Uber. He is the founder and executive chairman of Hyperloop One. And so join me on June 15th at 2 p.m. in the afternoon to have a focused conversation on moonshots, on how do you figure out what your moonshot is, how you target it, what are the advantages and sort of the fun of having a moonshot in your life. You know this is something I'm passionate about and really want my entire A360 family to be using in their day-to-day lives. So please help me in thanking Lewis one more time, and have a fantastic rest of May. Take care, everybody. Lewis, real
thanks.
pleasure.